Hello, everyone, and welcome to another exciting Quantum London webinar. Here at Quantum London, we're interested in understanding the business implications of quantum computing. What sets us apart from other quantum groups is our focus on trying to help non-technical business professionals understand what quantum technology might mean for them and their industries. We do this through hosting webinars like the one today, as well as some more informal roundtable discussions. We also run a community-led quantum computing coding group for those who want to get more hands-on. To be able to define the business impact of quantum computing more effectively, we've been looking to set up focus sessions and groups around different industry verticals so that we can start to have discussions about more specific use cases and timelines. And so to do this, we are kicking off today our Quantum and Finance series, which will be led by one of our community members, Esperanza. Esperanza is a senior leader for a global financial institution who is focused on doing things differently. She is passionate about quantum technologies and believes that they will help bring about fundamental changes at many levels. She's previously trained as an industrial engineer and has also studied quantum technologies at MIT Pro, QTech at TU Delft and IBM, amongst other institutions. When Esperanza is not thinking about all things quantum, she's compulsively reading or flying in her small simulator at home. In this first episode of our Quantum and Finance series, Esperanza will be speaking with the CSO and CEO of Multiverse Computing, who aim to apply quantum technologies and AI to financial industries and help companies in this sector gain an advantage with quantum computing. Our speakers from Multiverse Computing include Román, who is a quantum physicist and the co-founder and CSO of Multiverse Computing. He's also a partner and advisory board member at Entanglement Partners SL, the first consulting company in Spain and Latin America on quantum technologies. Román has been lecturing a variety of courses on quantum information, quantum computation, entanglement and many-body systems, mathematical methods and solid-state physics, and is the author of numerous highly cited papers on quantum physics and computation. We also have Enrique Lizaso, Olmos, CEO of Multiverse Computing, who is a professor in mechatronics engineering, finance and marketing. He has founded startups in blockchain and international health and is also the president of the Quantum for Quantum Commission. Enrique has more than 20 years of experience in the financial industry and was previously the CEO of Untitled. He's also a trained medical doctor as well as an aircraft pilot. So without further ado, I'll hand over to Esperanza, who will be leading the discussion tonight.
Thank you, Anahita. Well, Romana and Enrique should be joining us shortly. Here I see Román is joining us and Enrique is coming too. And well, I just wanted to share with you all that it's great to be here. It's a great pleasure and honor because I'm a great fan and admirer of the work you guys are doing at Multiverse. You also wrote the first paper that I read about quantum computing in finance. And one of the very few papers I have been able to find about this topic in, I think I remember correctly, it was published in 2018, 2019, and it was really a pioneering work. And this is actually a question I always wanted to ask to you guys, and I feel privileged to do so, which is, what led you to start thinking and exploring the intersection of quantum and finance?
So maybe I can start answering the question. First of all, thanks a lot. It's a pleasure to be here talking today, and thanks a lot for the super nice introduction, by the way. So what led us to explore about quantum and finance? You know, we come from very different fields. As you know, I come from physics, quantum physics, simulation methods. Enrique comes from finance. At some point, we had a working group of people where we were wondering whether, well, you know, we had this question. We're going to have quantum computers sooner than later because we are optimists by nature, okay? And then we thought, okay, we should be able to do something with them. And then finance is not an exception. We know that in finance, there are lots of very complicated and intractable problems. And well, there should be some application of quantum computing to finance, no? And then we started exploring. we saw at that time that more or less, well, there were some papers here and there, but everything was very scattered and the opinions were not too homogeneous. Everybody seemed to have a different opinion of what it meant to do quantum computing for finance. And then we essentially, we started thinking about that seriously and tried to understand, okay, exactly what can be done on finance with quantum computers now, a little bit later, and in the long term, okay? And that's what we did. Yeah, that was our motivation, to put a little bit of order, okay, in a field that was pretty chaotic at that time. Yeah.
And you did, absolutely. You did, absolutely. That paper is brilliant and is actually one of the reasons and things that I read and inspired me more to enter this field. And hopefully some other people in the audience might be inspired too. I haven't said this before, but we all would like this event to be as interactive as possible. So if you have any questions, please do not hesitate to post it on the chat, and we will find a way to also bring you all into the conversation. I see the paper I'm talking about. I cannot share it right now on the chat, but we will share it a little bit later. Enrique, there is also, there is anything else you would like to expand or to add to what Román has brilliantly explained?
Well, not exactly. One thing that when you just are starting a startup from the beginning is quite important is that the founders should know how to work together and how to plan together something to do. And this was this paper was our initial work. I mean, we were belonging to the Quantum World Association. We set up there a work group about quantum for quants, for finance, and so on. And in the work group, there were about, I think we were 10 people or something like that, or 12 maybe. And at the beginning, everybody was agreeing just to try to write or how to write this paper. But at the end, there were just only 4 people. That happens a lot during our lives and so on. So we decided from this paper just to start the company. That was.
So that's a great story. So it all started actually with a paper, and it's a beautiful story.
It actually started on a WhatsApp group. Okay.
Oh, really? Wow.
It was even, yeah. Before the paper.
So before the paper, there was a WhatsApp group, right?
Exactly.
Great. Yeah, sometimes the magic happens like this, right? You start a WhatsApp group, you start talking with people, then you start working on a paper, you build a company, and so on. And talking about this paper and also about your extensive experience on quantum computing for finance, would you summarize somehow the use cases in the case of quantum for finance? Would you share that a little bit?
Yeah, so absolutely. There are a few use cases where you can apply quantum for finance. Of course, this is growing every day as we speak.
Yeah.
Okay, but kind of the standard places, of course, optimization. There are of course optimization problems. Okay, where you can apply quantum computing. In finance, optimization is at many places. I'm pretty sure that Enrique knows that much better than me, but let's say portfolio optimization is a canonical problem where you have to optimize the investments or the trading trajectories in a period of time to maximize the returns and minimize the risk, say, for your pension funds, okay, or something like that. ETFs also is an optimization problem. There are lots of them. And nowadays with quantum computers, luckily, well, with a specific type of quantum computer, and here I'm thinking about D-Wave, quantum annealing, we can already start playing with very complex optimization problems with many variables and also with real data. Okay. There are also problems related to quantum machine learning. So there is artificial intelligence, there is machine learning, there is the quantum version of all that. Make quantum computers learn somehow recognize cats from dogs, okay? To put it differently, to be able to detect anomalies, to be able to classify more accurately than classical computers. And there are lots of applications here, say fraud detection, credit card fraud detection, anti-money laundering, customer propensity, marketing studies. I don't know. There are lots of applications here. And the nice thing about quantum machine learning is that these are types of algorithms that, believe it or not, they are kind of very well adapted to the quantum processors that we have nowadays. So they are small, they are noisy, we don't have too many qubits, they are a bit unstable. But these algorithms, you know, they are heuristic. It means that they adapt also to the actual hardware, and they can also run with very few qubits. And surprisingly, they give you results that are not trivial at all. Okay, if you want to reproduce them with classical computers. So the answer is yes. Well, anything that has to do with quantum machine learning has a potential of being applied pretty soon. Then there is also, of course, everything that has to do with pricing of derivatives, pricing of options. These are important problems in finance. And here, you know, standard methods, I'm thinking of Black-Scholes equations and so on. And then the people that are doing quantitative finance, they spend a lot of time solving stochastic partial differential equations, using Monte Carlo methods. Here, there are different options. One of them is to use quantum speedup for Monte Carlo methods through something called quantum amplitude estimation. This is also something possible. It's one of those applications that is going to be more important of quantum computers for finance, because there is a lot to be done in pricing. However, and that's in our opinion, we think that in order to be able to, I mean, one can play with toy models already, but if you want to play with real data, we think that you need more powerful quantum computers than the ones that we have today. And then there is the whole story about simulating economy. This can also be done on a quantum computer. Predicting a financial crash, simulating, a financial network. This can also be done with quantum computers because at the end of the day, they involve, many highly correlated variables. And this is exactly the thing that for which a quantum computer is actually built. Okay, there are many different simulation methods actually. We have some proposals on how to simulate economic markets. And that's also something that could be an interesting application for people. I'm thinking here of central banks and so on, when they introduce a measure and they want to test whether the market is resilient to that or not. So I'm thinking about that. I don't know if Enrique would like to add something about this.
Yeah, this is important. I mean, one thing is what you can do nowadays with quantum computing, and which things you can do in the future with quantum computing. But the real point, if you want to do something inside the banks today, is you have to take a real problem for the bank. If not, what you are doing is just running an experiment, which could be totally interesting, but you are going to face a lot of problems inside the bank just to get your budget approved and this kind of thing. So the key question from the practical side is you have to focus on the things that you can just run on the current quantum computers. And that, from our point of view, from the multiverse map of the world, to say something, reduce the problem to two things in the particular application of quantum computers. One is optimization problems, which are quite interesting because some of the problems that are inside optimization could be the killer app of quantum computing also. And the other one, as Román said, is the application of machine learning. And in this case, also, we have to take care or to pay attention to the fact that the solutions that quantum computing may deliver inside the machine learning, and specifically in training, can be much greener in terms of energy consumption than current solutions nowadays. So this is going also to play it's going to be of some value in the near future. The other two, as Román said, for sure, they are going to change finance as it's now, but probably we are going to need more powerful quantum computers. So it doesn't mean that you cannot do pricing, But if you are just trying to take on a real pricing problem, a difficult pricing problem for the bank, or trying to accelerate the pricing algorithms a lot, okay, this could be just too much for a quantum computer as today. And so if you run into that, probably you are going to show, let's say, allow me the word, a mediocre performance, or even, or you may take a problem that is already solved by classical methods. So maybe quite interesting, but the management from the bank are not going to pay for that in most of the cases.
That's right. That's right, Enrique. Absolutely. I love the way you both are integrating the more scientific and strategic views of quantum computing for finance and its application. And you, Enrique, said something really interesting about how a bank, or for any matter, any big corporation works. And our corporations and businesses pretty much focus on delivering value, and sometimes on tight timelines, so to speak. And it brings me to the following question, which is, who, in your opinion, inside a bank should be thinking about quantum computing?
Okay, I can share my opinion on that. When you are approaching to a bank, okay, you have different. A bank is not just a black box, or let's say a monolithic structure. Inside a bank, you have different players, and each of them has their own goals inside the bank. So you may approach, let's say, an innovation department. Okay, these guys are, if the bank is large, they are willing just to test new things and to try to do something, and just in the best case, just to put these things inside production. Okay, that's good, but in some cases you are not going to progress much further. That depends on the proof of concept or the test you have decided. You may also decide to go for the business lines. But in business lines, the only language that is usually understood is the language of money.
That's
is
right.
This solution going to give me an edge over my competitors, or are you going to provide me more income, or are you going to reduce my expenses? If not, no way. And you have to be used, or you have to become used to this kind of language. Any time that you go for, let's say, a business division or wherever, you have to explain in terms of euros, dollars, or whatever, why, if you apply quantum computing for this specific solution, that may be okay, an increase in revenues or a decrease on expenses, or you may do something that you couldn't do before. So this is as if you are speaking English, and at some point you know that the management is speaking Spanish. Okay, you have to change your language. You have to explain the same things in another language. So this is the point. Okay, Román, for sure, they have another view, but he has also the direct experience of these two particular languages.
Yeah, maybe Román, you can share some insights also on this question.
Yeah, well, I think Enrique explained it perfectly well inside of the bank. So you know, the bank is not monolithic. You need to. It depends on what type of bank, who is thinking about quantum. Could be the innovation guys, the production guys, the management guys, and then it actually depends. Okay. From our experience, we've seen that innovation people in banks are interested, of course. Now it's starting to, in some banks, people in production lines also, which makes it extremely important. Okay, but yeah.
Yeah, great. I have a question here by somebody in the audience, and if it's okay with you, I would like to post it to you live. And his name is Eric Barr. I'm not sure if I pronounced right your surname, Eric. My apologies. And Eric asks, are annealers he asks about quantum annealers, about whether they are the most appropriate for optimization, and have you come across other quantum computing applications, cases using other quantum computing platforms, which, in your opinion, shows the most promise as of today? Well, thank you, Eric, for this question. It's really insightful.
Good, thank you, Eric.
Yeah,
and thank you,
great.
Esperanza. It looks like you spelled the surname correctly according to the chat. So
yeah, thank you, Eric.
Yeah, okay. So to answer your question, yes, we are exploring and have been finding applications to other platforms. Of course, quantum annealing for optimization. That doesn't mean that you cannot do optimization with universal quantum computers. You can also do it. It's just that as of today, they are still a bit limited for that. Nevertheless, having said this, yes, we use universal quantum computers, gate-based quantum computing, such as the one being provided by IBM, for instance, or IonQ, okay, or these other companies, for quantum machine learning applications. So everything that has to do with classifiers, for instance. These are variational quantum circuits that you have to optimize and so on in an heuristic way. This is run on universal quantum computers, okay? And right now, we've been doing things with, as I said, with IBM, with IonQ, and also with other platforms.
Yeah, Enrique, any other views or insight you would like maybe to share on this matter?
Oh, no, one thing that I have learned during my life is just not to meddle with the technical guys when they are just stating something that is for sure real.
All right. Then Enrique, if you allow me to ask you this question, which is more maybe on the management side, so to speak. If a middle manager approaches you in a bank about quantum computing, how would you engage him or her into the conversation about quantum computing?
Oh, okay. I think that this is the question about, if I have understood well, correctly, is about, okay, I am a super fan of quantum computing inside a bank, and I have a middle manager, which is maybe my boss, and I have to sell him the idea of just doing something in quantum computing, or at least giving some money to me just to try to do something about
yes, that could be a great that is a great understanding of the question.
Yes, this happens, and this happens a lot because one thing that a point of view that you may have here inside the banks and large banks is that maybe you have technical staff, okay, they may even be managers, but they are classified as technical staff, and then you have managers which are not technical staff at this particular moment, and basically even they may not be technical. I mean, this is a super nice movie. I think it was called Margin Call.
Yeah, I have seen it. It's brilliant. Maybe somebody in the audience have seen Margin Call too. It's brilliant.
Okay, this is quite important. It was quite funny, but this is for real. I mean, if you are approaching a middle manager or even a high manager, a management guy about this one, you have to be prepared to explain that if you are applying this particular thing of quantum computing, the probability is that you are going to have this change in your profit and loss statement or whatever from the department is this one. Also, you may just play the card of, if we don't do that in some particular departments, let's say, for example, if you are just computing the capital requirements from the bank and so on, you may say, okay, we have to explore that. But then, if you choose this way, you have to have a very clear idea of what the other banks are doing.
That's right.
Okay, it may come as a surprise, but if you take, for example, the top 50 banks of the world by volume of assets, Chinese banks excluded because we don't know exactly what they are doing there. But you will find that most of the banks of the top 50 are doing something in quantum. So
That's right.
In a lot of banks, if you say, okay, look, the competitors are doing that, this may be applied for this, for this, for this, maybe it's time to think about just budgeting a very small thing, just to try and see what happens here about that.
Yeah.
This can work. I mean, I have experience in my previous financial life, and this may work if you do that. Please don't make a mistake, which is trying to explain the computing and just with a nice, super nice equation, and then you will have exactly the same answer that in margin call.
Yeah, that's a great example, Enrique. That's a great example. Maybe Román, you would like to expand a little bit.
As a physicist, I also learned when the finance guy is talking, not to interrupt him.
That's great. I have here some questions also from the audience, and I would like to pose some of them to you. First, I would like to apologize to the audience if I cannot share all the questions with our guests, but I'll try. So sorry again for the spelling if it's not correct. Dira Subarna asks, have you any of your proof of concept in production?
Yes.
Wow.
That's it. Next question.
That's it. We can say anymore. Yes, we have. All right. So, of course, some member of the audience may understand there are some limitation of the information you can share.
We have some confidentiality agreements. We cannot share.
Yeah, I agree. But
some of our books have gone into production. Yes.
All right. So I hope this answered the question.
It's about optimization in particular.
Yeah, and you can't read until that point, right? This is all that you can say, and I deeply appreciate that you can. You can share the question.
We are going to have.
Yeah, I imagine at some
production and in some other particular field, but probably they will be announced in the following month.
Yeah, it's what I was going to say. There might be some press releases about that, so I will also encourage the audience to keep an eye on that. Sure, great. I have more questions also from the audience. I'm keeping them in mind, and I'm trying to balance the two things, right? But I keep you guys in mind. Here's another question for you two. This is something that I also think a lot about, and I'm very interested in your views, which is which application of quantum computing for finance do you feel it can be a gut feeling? Do you have the feeling that this could be really disruptive for this industry?
So
this is a tough one, I know.
No, this question has been answered before. I mean, and not by us, because we may have an opinion of everything, but by Boston Consulting Group themselves. I mean, there are two applications that are going to be disruptive in the future, probably. Okay, not nowadays. The first of all is the capital allocation. Okay, and this runs in the sense that, if you think that we are inside a period of low interest rates and high credit risk, so you have to use your resources, that means your equity, in the most suitable way. So that is what could be a killer app, optimization of the capital allocation. But unfortunately, just for doing that, you have to be able also to compute efficiently the risks. And that means, in some cases, using some kind of Monte Carlo or quantum enhanced Monte Carlo and so on. But this is one, according to them. The second one, which is also disruptive, okay, is precisely this one that we cannot run on quantum computers as today, which is the evaluation of the risk, or in other words, of complex financial instruments. Okay, it's not only about options, but it's, for example, securitization, tranches, and these kind of things. This one also is a killer app. Here, and this is a useful insight, it's not even necessary to demonstrate quantum supremacy. I mean, even minor increases in the speed of computation are of value, of real value.
Yeah.
Okay, because the only option that you have when you are running a complex pricing and you are making some assumptions and you are just making some reduction or value reduction or whatever you want to, it's just if you know that you are doing this simplification, you have to increase your provisions. Your provisions, I mean your capital allocation there, so that draws the value or the profit of the total operation lower. And this is something that you have to avoid. So, okay.
Yeah.
But this is from the point of view of people that know much more than us about finance.
Any more insights on this question, Román?
No, I think he explained very well. Yeah.
All right. Then I have here another question from the audience, and it's and here I would like to have both a more technical and scientific side and also business side, which is a very interesting question that Pipin Pal is posing. And he says, what are some challenges that quantum computing might face in the few upcoming years? And I like this question because it has a technical side and also a strategic and business side. So maybe, Román, if you can start explaining this a little bit more on the technical side and scientific side.
So on the technical side, the challenge is clear. We want to get bigger quantum computers, okay? And for this, that's a summary.
That's our dream.
That's the dream. So we need to be able to scale them up, be able to reduce the level of noise, increase the fidelity of quantum gates. Then we have to be able to test also different types of technology. Because you can build a quantum computer in many different ways. You can do superconducting qubits, you can do ion traps, Rydberg atoms, photonic quantum computing. You can do lots of different things. Each different platform has advantages and disadvantages.
Yeah.
And but still, we need to find a way of scaling up the technology. I think that's the main problem, the main challenge of quantum computing as of today. We have proven that we can build 50-something, 60-something qubit computers with ion traps or with superconducting qubits and so on. Okay, with more or less efficiency, accuracy, speed up, whatever. But now, no, we want a 1 million qubit quantum computer. How the hell we do that? No. So,
so that's a great question.
That's the challenge. How do we scale this up?
Yeah.
We need the quantum analogy of the transistor.
Absolutely.
Okay. So in classical computing, so in classical computing, the transistor allowed to miniaturize everything and then scale up classical computers in a massive way. That's the challenge that we have now. How do we? What do we do to go from 50 to 50 million? Okay.
Yeah.
And there are some ideas out there on how to scale up quantum computers. Maybe we have to parallelize them and connect them with optical fibers or something. I don't know, but that's a big challenge as of today. Okay, that's from the hardware part. Yes, and also from the software. From the software, there are also challenges, which are, well, we need more quantum algorithms.
Great.
Building algorithms is not easy because, especially quantum algorithms, because they don't follow the usual intuition. We don't understand completely some of the tools to build these quantum algorithms. It's kind of complicated. It looks like there are some families already, but we need more quantum algorithms for solving more problems.
Yeah. Yeah, and it's in the field of quantum algorithms, or more broadly, quantum information science. Yeah, it's very challenging, right? Because as you said, it defies conventional wisdom and the way we are used to think in those mathematical terms. And we might even need to develop new parts of mathematics and new parts of information theory just to get to the algorithm part. So yeah, that's an important challenge.
Yes.
Enrique, sorry, Román. You don't want to enter into this. More on the business side, you say no. I'll just stay into the scientific and technical. It's okay. It's okay. We can leave it here. Yeah, I understand. I understand your point of view, because there is also a certain degree of uncertainty, which makes it difficult to talk about challenges. So if I had to address this from a business and a strategic side, at least publicly, I would say the same as you did. So here's another, let's say, more more practical question, and I'm sure you can leverage a lot on your experience with quantum in companies. Is which are the steps that companies are taking in a quantum journey, and which, in your opinion, should, in a sense, be the step to take?
For a company in general, yeah, probably that's more for Enrique.
In general, maybe it's too broad. It's actually for a company in finance, working in finance.
Yeah. You are right. This is complicated. You have the companies that are just deciding to try something about quantum from the innovation department, for example. And then they say, okay, we have this super nice thing, which is the quantum computing, and now we are trying to look for some problem that we have here. Okay, so this may work, or maybe it doesn't work. But at this particular moment, for me, it's complicated to say whether this is the good approach or not. For sure, this is a good approach to start, because the company should just get inside this hustle of quantum computing and trying to do that. But if you find the wrong proof of concept, you are going to make your company just get out of the quantum industry. I mean, this has happened before. Also, some of them are building their teams, and this is important. Okay, we all recognize that specifically for the large banks, it's important to have a team that knows about quantum computing and so on. But in some cases, these teams are just working inside, let's say, not exactly a bubble, but with not enough exposition to the financial problems. And this is important. These teams should be multidisciplinary. This is important.
Absolutely.
Because if not, you are going to go probably on the wrong direction. We have a super nice example of what should be, or an analogy of what we should be doing with a quantum computer right now. And finally, there are some other companies that there are quite very few, but it is the general management who decides to do something and then just want to have some proof of concept about what about quantum computing is and so on. And in some of these companies, they prepare, and this is a good thing, a set of problems that you may have a look at and decide, okay, this is doable, this is not doable, this is doable, and this is not doable. Because at this point, you are just narrowing the entrance on the quantum computing, and you are making basically a successful approach to the quantum computing, okay?
Yeah.
But on the other case, if you select some other thing that you think that is going to be disruptive in 10 years and you try as today, it doesn't work. So how to train your workforce? Okay,
Yeah. That's a very good question.
This is complex. Maybe you may go for the academia, just hire some people and so on, and then perfect. But if you want the real training, you have to apply. I mean, to a particular case. Just to think, I mean, artificial intelligence is a field that is already established and you may use and so on. Very few people are just trying to sell artificial intelligence. So they say, okay, let's try to do that. No, people want just to save money or whatever.
Yeah.
In particular, I think that is very good from Román, if you can remember, Román, how the analogy of a quantum computer and Siri.
Yeah, that's a good one. I mean, that's something very important to keep in mind. I mean, if you want to do quantum algorithms for finance, you have to try to target realistic things that can be done today. Okay, so say imagine that you have the Apple One, okay, the first version of the Apple computer, all right?
Right.
And say, what can I do with this? Okay, and then somebody comes to you and as you know, I want a voice recognition system that can, you know, can make me tea and make a call to Amazon or whatever, essentially Siri, no? And no, this machine is not for that. You cannot do that. Okay, what can you do with? Oh, but then you say, oh, but this is useless. No, it's not useless. You can do things. So what can you do? You can do spreadsheets for, you know, for doing your finance. You can do Microsoft Excel and so on. Is that useful? Well, of course it is useful. Okay. Would it be cool to have a voice recognition? Would it be cool to have Siri? Yeah, it would be super cool, but we still don't have the machine to do that.
Yeah.
No? So we are finding a bit the same situation. You cannot ask current quantum computers to do, you know, the Siri version of an application. You have to ask them to do what they can do now. Okay, and you have to find the correct application for what they are useful now. Okay, and I think that's very important. I mean, we have had that we had that very clear right from the very beginning. Okay, in particular in finance. Yeah.
Great.
We found this particular case that some of the customers we have, the approach has been started by the bank, and then the first thing they ask us is, okay, where should we start from? Okay, we want to do something about that, but can you just give us some hints about because the people in the bank, the one who is approaching you, the manager, is also putting his prestige, okay, his career in the bank, and he is betting for you. So you have to help them in identify which is the case that is going to make him escalate to another position. This is the point. If you get this point, you are not wrong.
Yeah, that's a very good point and a very insightful and very deep understanding of how a large corporation works. I have here another question from the audience, and this is by Michelle Kurek. And Michelle asks if you feel some kind of reluctancy from banks about sharing their models or their data, particularly. And here Michelle is asking a question straight to the point, because up to my knowledge, no bank now owns a quantum computer in their data centers, to my knowledge. So if we start thinking about doing things of quantum computers with real data, somehow we need to move that data to the cloud and to execute computations on the quantum computer, which is outside the bank infrastructure. And this can be something delicate for banks. So maybe you can share some insights about this.
You want to?
Yeah, as we saw, I mean, I mean, it's true. So banks are a bit reluctant to share their data. I mean, in some situations, the data is public, and then there is no problem with that. But when the data is not public, then it's true. You have to work inside of the perimeter of the bank, okay? And you have to develop the software inside the perimeter, the safe perimeter of the bank, and so on. And when you have to connect to a quantum computer, which is on the cloud, you have to be sure that what is transmitted to the quantum computer is not compromising the data. Okay. Many times it does not compromise anything that is critical for the bank. Why? Because, well, at the end of the day, say if you are solving an optimization problem, let's say, what you are sending to the quantum computer is a formula,
Yeah.
with some coefficients and so on. And if you don't send any more information, then nobody knows what this is about. This could be about critical information for a bank or about my last recipe for macaroni or whatever. So nobody knows. So in that level, that's perfectly fine. And if there is something critical to be transmitted, that usually is not the case, then it has to be ciphered, randomized, anonymized, or encrypted. Okay. We've been working with anonymized data for some projects also, because for some projects, we even didn't have access to what the data was meaning. And even though we were working inside of the perimeter. So that case as well, there are always solutions to that.
Yeah, we have been faced with, in one particular project, it's public now, we were working just to detect tax fraud, which was the value-added tax. This is an European product, as European as the classical music, the fraud in the value-added tax.
Yeah.
We were forced to work inside the perimeter of the tax agency, not completely.
Wow.
And with,
please.
I was going to say
Román.
that, and the data was also randomized and so on. So we also didn't know what the data meant. We just had generic features and that's it.
Mm-hmm. Very interesting.
Michelle is
please,
right.
Please, go on.
Banks are always reluctant always to share their data. That depends on the data and of the project itself. If you are just running some kind of, let's say, scoring or whatever, you are going to run into problems, but they have experience in doing these kind of things before with artificial intelligence. So there is most of the banks, there is a path. If you are just going just to help them in, let's say, in some kind of algorithm to be applied, or to develop an algorithm to be applied in high frequency trading or wherever, you are not going to see the real problem. Never ever. You are going to be asked to provide a tool that does this specifically, and that's all.
Yeah, I can imagine, and it all depends. It also relates to the sensitivity of the data, very delicate data, and also regulation. It's a complex matter.
Yeah.
I'm going. Well, we are in a way. I wouldn't say running out of time, but leading more towards the end of this session. I have two questions. One, let's say that we have been thinking about, and then another from the audience. And if we have more time, we will tackle more. The question I would like to pose to you is, from your point of view, which are the risks that banks and financial institutions face if they are left behind of the so-called quantum revolution?
That's a good one. I think it's very clear. If you, there is an ecosystem here of banks, okay? And if you are a financial institution and you don't want to step into quantum computing, well, what's going to happen? That your competitors are going to do that, okay? And you say, no, it's not important. And then in 5 or 6 years' time, you will see that your competitors have already, rocket in that direction because quantum mechanics is not something that you can learn by watching a couple of YouTube videos. I always say the same. Okay,
Yeah,
you need
right.
time. You need time. It's like good wine. Okay, it needs some time.
Yeah.
So, and by that time, in 5 or 6 years, your quantum computers are going to be more mature. Your competitors are going to be performing things that you are absolutely unable to even reach or grasp or understand, and you are going to be out of the market. It's as simple as that. So that's the risk that you are facing. Total failure, I would say.
Yeah, it's a very existential risk. Enrique, please, if you want to share some other views.
Quantum computer is a new field, but we can think about just, for example, machine learning of these kind of things, or even quantitative finance. I don't want to use quantitative finance. Then you are just refusing to do some kind, for example, corporate and investment banking or these kind of things. That depends on the bank, but I think thinking that this is could be dangerous just to avoid this kind of things. Can you imagine a bank today without IT systems? Well, it's difficult to think about that. For sure, you may run a bank like that, but it's a private bank, it's quite small, and so on. If you decide not to use this kind of instruments, not to go inside, okay, maybe you have a problem. And it's also important to remember, I don't remember, please forgive me, there are somebody from, I don't remember if it was JP Morgan or Morgan Stanley, but these are not longer banks. They define themselves as kind of IT company working in finance.
Yeah, that's right.
And
That's a very good definition.
Unless you know how to code. So
yeah, we are talking here about existential risks and about deeper questions about what does it means to be a bank nowadays. And you are absolutely hitting it on the nail. I have another question here by Kevin Corella. This might be our final question because of time restrictions. There are many other questions that we have been unfortunately not able to tackle from the audience. And Kevin asks, it's I think an advanced question. I'm not sure if I'm going to be able to correctly transmit it to you, but maybe Kevin can also expand a little bit more of the question on the chat. And Kevin says, in the context of development better financial theories, the researchers need financial theories to restrict machine learning propensity to overfit. From your experience, or I would add your knowledge, what is the best framework in order to avoid this issue in quantum machine learning? And it's a complex and advanced question, really.
But it has a very simple answer.
Really?
Exactly as in machine learning. So in quantum machine learning, we are not inventing new models or anything. We are just inventing new algorithms, okay, that can fit the data more accurately or detect anomalies more accurately or identify fraudsters more accurately and so on. And the risk for overfitting is exactly the same as in classical machine learning. So it's exactly the same. We need financial theories to avoid overfitting as well.
Yeah, that's a great insight. And Enrique, maybe some other views on this matter? On in general,
on technical side after talking Román?
No. I was trying to reframe a little bit about the business impact of overfitting in general, both in quantum as classical.
Yes, if you exactly the same as in machine learning, if you do overfitting with quantum computing, then you are going to have a model that is useless, that is going to perform poorly, and then you are going to be your company just expelled from the bank, and maybe you are not you are going to run into problems. That's for sure. So, but this is something that the audience already know. This is the way that it is. Overfitting is a large problem, and it's not only restricted to the classical machine learning. In quantum machine learning, as Román has said, it also happens.
It's exactly the same. Yeah, overfitting. I mean, the procedure is exactly the same as in classical machine learning. You have, I mean, if you deal with classical data, which is what we are thinking about here, we are not talking about other types of algorithms. We have classical data. And then there is a training set, a test set, and a validation set. You have to avoid overfitting. You have to do validation, cross-validation, and so on. That's exactly the same. What changes is the algorithm, that it can be more powerful.
Yeah, very, very, very interesting insights for sure. I have also here, well, we are now leaning towards the end of the session. Again, I apologize to those in the audience who posed question and unfortunately couldn't be tackled in this session. And I have here a message from Alex, which I feel is a good way to, in a sense, closing the session. And Alex says, great to see the presenters. I have been following Multiverse papers for a few years now. So Alex is one of your followers in a sense.
Good, appreciate that.
Thank you.
Yeah, it's always those events.
Ali, send us your curriculum.
Yes, because I just want to add something if you let me.
Of course. Please do, Enrique.
Yes, send to us the curriculum because we are hiding. And if you think that you are wasting your life doing what you are not doing what you don't like, please call us, drop us your curriculum, and let's talk. We are the guys from Multiverse Computing. We have even a totem there, so come here. And yes, we work in serious field, which is quantum computing for finance. Thank you.
Exactly. Yeah.
So,
believe it or not, we are serious guys.
You are, but Alex is having a good laugh here. He says he's connected to you, Román. He's Alex Khan, also well known in the community. So Alex, it's so to speak, the offer is on the table now. Everything is up to you. I don't want either to put anybody in any compromise, so to speak. But it's great talking to you guys. It's great the atmosphere that you create. And I really appreciate having this talk with you. It's great. And also from all the people in the audience who had joining us today. So Anahita, welcome back.
Thank you so much. Thank you all. Before I say final thank yous to our speakers, I just want to let our audience know about a few upcoming events. So next week, Wednesday, the 26th of May, we'll be having another Quantum Stammtisch. To anybody who's not attended one before, they're informal roundtable discussions we host typically every month. And it's an opportunity to come and connect with people from the community and ask any questions that you have. And there's no such thing as a stupid question in any of the Quantum Stammtischs. And we're also going to have our next quantum computing coding session on the week commencing the 31st of May. Just look out on our social media pages and we'll be confirming the exact date on that. It'll be either on the Bank Holiday Monday or on the Tuesday. So thank you so much to Román, Enrique, and Esperanza for that fascinating discussion. It was an incredible way to start off our Quantum and Finance series, which Esperanza will be continuing with us. It was incredible to hear all of your insights, and thank you for both your time and for your answering of the questions. Good night, everybody.
Thank you for having us.
Thank you very much.
Thank you.
Bye.